Welcome to lesson 2 of our Information Technology Specialist series on Python. And I want you to imagine you walking into a shop with, let's say, an amount of money. It can be in any currency, which is 20. You decide to buy bread for 1.75 and milk for 1.25. So the shop attendant calculate your total by adding the 1.75 and the 1.25, giving us a total of 3. Then she decides to subtract the 3 from the 20. Now you will be left with 17. And she finally prints out, "Thank you for shopping," on the receipt. So notice how in this one shopping trip, some values are whole numbers, which is the 20 cedis you had or the 20 pounds or dollars you had in your pocket. And we have some decimals, which is the 175 for bread and the 125 for milk. Then the word which was also printed on the receipt, which is "thank you for shopping." So the words or the text. Then when you finished, you had a change of what, 17, and that is how much money you had on you. So do you have enough money? You can say yes or no. So this is exactly how Python works. So Python uses expressions to calculate results, and Python automatically assigns data types to each result, and that is what we'll be exploring in this lesson. So I'm going to focus on the first major objective, which is the operations using data types and operators. And under that, we're going to evaluate expressions to identify the data types Python assigns to variables. So we'll talk about variables, we'll talk about data types. So let's get started. So we'll look at the string, the int, the float, and the bool. And this is what we're going to focus our lesson on. So just brace yourself, and it's going to be an exciting lesson. So we're going to work with primitive data types. So in programming languages, a data structure is a method for organizing and managing data, while a data type refers to the type of data itself. Data structures fall into two main categories: primitive and non-primitive. So I want you to bear this in mind. A data structure is a method for organizing and managing data, and the data type refers to the type of data itself. Do not forget this. So primitive data structures are the most basic form of data representation, whereas non-primitive structures are designed to organize and manage collections of primitive data. So we use data types to define the nature of the data stored in variables. And this takes us back to our secondary school days or university days where we were given simultaneous equations: x plus y is equal to 20, x minus y is equal to 10, and we are being asked to find the values of x and y. So depending on the type of equations that you are given and the numbers, the value for x and y is always changing. That is why we say that x and y are variables. So that is what we're going to explore next. So here are a few rules to follow when creating variables in Python. So it's a language and you need to adhere to its syntax and its rules. So if you don't go by the rules, then you're going to make a lot of mistakes. So the first rule here is variable names can include letters, numbers, and underscores. Good. And names must start with a letter or an underscore, not with a number. And spaces are not permitted in variable names, and avoid using Python keywords or function names as variable names. So as you progress, you will get to identify, okay, what are some of the Python keywords? What are some of the function names? So as we do that, you'll get to know them. So just don't worry about that. And choose names that are concise yet descriptive. Avoid using single letters. So please do not use single letters for your variables. So if you have a variable and you want to assign a value to it, do not, all in caps, use single letters. So what are these primitive data types? So Python has four primitive data types. We have the integer, the float, the string, and the boolean. So if you want to find out the data type a particular variable is being identified with, then you use the print, then you type, then you put the data in there in a parenthesis, then you get the output. Okay, so you see an example code here. So we have the first code being equal to hello world, which is a string, so a bunch of text. So we put it in inverted commas. Then the age, which is a number, 42, case, and the cache, sorry, I beg your pardon, 3.14 is also a number, but this is decimal. This is a whole number. Then U, which is a true or false. So if you're going back to the shopping trip, where, okay, do you have enough money? He said yes. So that is a true. If you do not have enough money, then that makes it a false. So how do we do this? So you print the type. So we're going to explore that in a bit. So I already have this set up. So just open your idle and let's start with this. But as we progress and as we get to chapter 4 of the IT specialist, we will switch to Visual Studio Code where we do some more advanced stuff. So just let's practice with this for now, okay? So we're going to assign our variable. So our variable in this case here is first code. So this is your first code. So we use this as comment. So this is an example code. Example code. So if you want to create comment within Python, you use the hashtag for now. So let's see. So our first code is equal to hello world. Exclamation, I close it. Once I hit enter, the system has taken it. Okay. Age, so we assign a variable with the assignment operator, which is the equal to sign, 42. Enter. So cache is equal to 3.14. Enter. Then U is equal to true. Enter. So now I'm going to print. So print, then I'm printing the type of data. So the data type. Then I'll call the variable name, which is first code. Now close my parenthesis. I'll hit enter. Then it tells me, oh, this is a string because it's a bunch of text in inverted commas. Then I was okay, print. What type of data is that? So the type is age. So that is the variable's name. I'll hit enter. Oh, this is an integer. That's good. Then I'll print the type of data. I'm looking at 3.14. I'll hit enter. Oh, that's a float. So in Python, decimals are termed as float. Good. Then I'm going to print again. The type is what? U, which is our variable. I'll hit enter, then it tells me bool. So that is a boolean. So this is how you find out about the data type. And this is how you also assign values to variables. So we need to adhere to all the rules I introduced. So it should start with a letter, it cannot start with a number and all of that. So please just go through it. Small, step by step, you will get it. It's not a rush. Okay? Well done. So integer, so like mathematics, an integer in programming is a whole number that can be zero, positive, or negative. And float is a floating point number. So it's a real number with a decimal point such as 10.8 or minus 278.9098. It can be either rational or irrational. Once it's a decimal, irrespective of it being positive, negative. So to check if a value is a float, we use the isinstance function. So as you progress, you get to know the functions and the methods. So we're going to go through that. So is instance 9.2, we are asking, is it a float? If it's a float, then true. If it's not, then it's false. Is instance 9.2, is it an integer? Then we get the answer. Is instance, is it an integer? Is it a float? So it will produce true or false. So we can test that. So I come testing for floats. So testing for float. So is instance. So is this instance 9.2? Is it considered as a float? So check for me. Oh yes, it is true. Okay, is instance. Is this considered as an integer? Is it an integer? What do you think? True or false? Oh, it's false. Yay! It's instance. Okay, is this an integer? Oh, yeah, it's true because we don't have decimals. It's instance. Is this a float? No, it's not. So it gives us a false. So we use this as instance function to check whether a value is a float or not, meaning is it a decimal or not a decimal? And I believe that is quite clear to you. Thank you. So integers lack a decimal point, while floats have one. So 22 and 22.0 are different types despite having the same value. So you know, oh, 22 is the same as 22.0, but when it comes to data types, they are different. So you can convert integers to floats using the float function. It's as simple as that. So if the age is 35, then we just want to convert it into an integer. So how do we do that? How do we do this? So sorry, this should be age. It shouldn't be number because the variable here is age. So let's see. So I'm going to define my variable. Age has been assigned the value 35. So I want you to print, and this should be lowercase because Python codes are case sensitive. So please take note of that. So float, I want you to convert this age into a float. I'll hit enter. Now it's 35.0. Does that make sense? I believe it does. Then maybe some age. So some age here is what? 33. Let's find out. Let's make this some age which is in quotes, meaning it's a string. So how do we convert that? Okay, so some age is equal to what? In quotation. So once you do this, then you want the system to recognize it as a string. But how do we change that? So print it as float. Then we will call the variable name some age. Boom. Now we get what? 33.0. Does that make sense? Does that make sense? Yes, I believe it does. Hold on. So string, we say, is a sequence of characters enclosed in single quote or double quote. So in Python, you create a string by placing characters within these quotes. Okay? So string in single quotes looks like this, and strings in double quotes looks like that. So in Python, strings are immutable. So don't forget this word, immutable, meaning their value cannot be changed once declared. Instead, a new string object is created if modifications are made. So once you declare, you can't go back to change it. So if our first string here is equal to hello, and our second string we are saying is the same as the first string, and we decide to print the first string, then we're going to get a hello because it's still the same. Okay, and when you print the second string, you should still get the hello. So let's test that out. So I've got my first string, which is my what? Hello. Then my second string, which should be equal to my first underscore string. Then I want to print my first string. Ooh. So what happened? Okay, I'm getting an error. So first string, print first. So I made a mistake with the spelling of first string. So these are some of the errors you will encounter. So you can see here. So print first string. Boom, we got a hello. I want to print second string. And what do you think I'm going to get? Still hello, because we said the second string is the same as the first string. Okay, now let's change the first string. Now we say first string is equal to hello Falma. So we are talking about the immutability of strings. Now let's look at it. So our first string is equal to my name, hello Falma. Then I want to print my second string. So now I've changed the first string. I want to print the second string. You see? And I'm still getting what? Hello. Because we defined the first string as hello, and we decided to equate second string to first string. Now we print first string. So that first string is still there, even though we've changed. Oh, I made a mistake here. Hold on. First string, my R, is equal to hello, Faoma. Boom. Now I want to print, so we've changed the first string, print a second string. And I'm still getting what? Hello. Does that make sense? Good. So you can change the case of a string using the following methods. So we have the title, the upper, the lower, and we can do this in Excel. So I don't want to digress, but in Excel we have the upper and the lower functions. You know what I mean? So before we dive in, note that a method is an action Python can perform on a data, and each method is followed by parentheses or brackets. So it's the action it performs on a particular data. Okay, so let's see. So my first name is Fifi. Okay, so I'm going to do first name being equal to Fifi. Okay, so why are we getting this error? Because it should be a string and I did not add my quotes. So first name is equal to Fifi. Good. Now I want to print, so please it's lowercase, print first name, and we are adding the method. So dot title. Okay, dot title. So Fifi is in lowercase. Now I'm applying the method to it. Now F has been capitalized. So that's the use of the methods. So it formats each word in title case with the first letter of each word capitalized. Okay, so let's say last name is equal to, let's say last names is equal to Faoma Oben. Let's test it out. So print last name dot title. Hit. Okay, so I made a mistake here. Last names. So print, it happens. Last names. Okay. print last names dot titles. So when you get an error, last name dot title. Now let's see. So you see a capitalized F, a capitalized A. So that is the use of the title method on a particular data type or on a particular data or on a particular variable. So don't forget that. So this is our variable dot the method. So title. Well done. Then we can also do upper. So it formats each word in what? Uppercase. So we can still do the same. So I want to print last names dot what? Upper. Hit. Now you get all of these in uppercase. Well done. Then we have what? Lower. So it formats everything into what? Lower. So I'll maybe define a new. So the lower method is equal to Fifi Fawoma Oven. Then I'll say print. Okay, then I'll call the variable lower method dot lower. So the lower method is our variable and it's been assigned a name all in caps. Now we get all of them in lowercase. So you see the beauty of applying methods to our variables or the data. Well done. So we can do the same first name Fifi print the upper. So which I've already done. Okay. Then the lower I've done that. Now we get to another part which deals with concatenation. So concatenation in its simplest form is trying to put different strings together. So in Microsoft Excel, if you've got let's say a value in cell A1, another value in cell B2. So cell A1 is, let's say, Fifi, cell B2 is cell B3 is Gmail, cell C3 is .com, and you are using concatenation, it will just combine all these cells into one cell. So all the items in cell A1, B1, C1 will be combined and put into cell D1, and that is what concatenation is about. Okay, so if you join the Microsoft Office Specialist, you will learn more about that when it comes to Excel functions. So let's look at this. So the first name here is Fifi. The surname here is what? Robin. So the full name, we are concatenating. So in concatenation, we use the plus sign, okay? So how do we join that? So I'm going to have define my variable f name. Okay. So f name is equal to, so we want a string Fifi. Then surname, S name is equal to Oben. So if you want our full name, so our full name should be equal to the variable, which is F name, plus, and we want a space in between the first name and the last name. So inverted commas, I hit my space, inverted commas, space, I'll do another plus, then S name. So I've declared it. So if I want to print, I only print what? Full name. Now it will do the job for me. Fifi Oven. Okay. So if I want to print full underscore name dot, let's say, upper. So we're applying the method. So you see how it's all coming together. Good. So that is exactly what has happened. So if you want to do title, so print full underscore name dot title, then it will change it capital F, capital A. Well done. We have F name as, let's say, Kojo. Then the age is equal to 40. And I want to print the first name, okay, plus, so I need a space, plus is, plus, I need another space, plus, and I'm going to use string. So we want to convert the age into a string because if you're concatenated, it should be a string. So yes, oh, that's it. Hit enter. Now Kojo is what, 40 years old. So I should have added a space here, but I did not. So that's about it. Okay, well done. So have too much space. Extra spaces can be common, especially in user supply data. So Python provides built-in methods to remove extra spaces like the S strip, left strip, and right strip. Okay. So the strip removes the white spaces from both ends. So that is what you need to understand. Then the L strip removes the extra white space from the left. Then R strip also removes the extra white space from the right. So how do we do that? So we have food is equal to Gary. So if you want to use the method on it to remove the extra spaces at both ends, then we can do that. Okay? So let's see how this is going to pan out. Okay. So I've got food being equal to 1, 2, 3, 4. Gary, 1, 2, 3, 4. Now I want to print food. Now let's see the result, Gary. So have you seen the extra spaces? Good. Now let's move on. We're going to print food dot strip. So that is the method being applied on the data. You hit enter. You see all the white spaces before and after. We've removed them. So print food. And I want to remove the spaces from the right. So R strip. So let me bring my parentheses. Now I'm going to close it. I'll hit. So it removes the one on the right. So if I want to remove the ones on the left, food L strip. And that should remove the ones on the left. So this is how you remove extra spaces. So still on strings. Now we move on to Boolean. So the Boolean data type has two values, true and false. Booleans represent truth values in logic, which informs computer science algorithms. So the term Boolean is capitalized, named after mathematician George Boole. Similarly, the values true and false are always capitalized in Python. So the Boolean, which is equal to 10 greater than 20. So if you want to find out if indeed 10 is greater than 20, then you print. When you print, you either get a true or a false. So let's look at it. So we're going to declare a variable, the Boolean is equal to 10 greater than 20. And we want to find out, is it true? So I want to print the Boolean, which is the variable. So that's false. 10 is not greater. So this is how you use Boolean. And let's also discuss comments in your code. So comments are crucial for teamwork and for reminding yourself of your code's purpose months later. So in Python, comments are indicated by the hash mark, which I explained in my presentation. So this is a program by Fifi Oben, creating a variable called name and assigning it the value Fifi, then printing it. So at least once you put in the comment and you come back months later to look at the codes that you've written, this will at least help you remember what you've done. Good. So the name is Fifi, then you print the name. So that's a comment explaining what you've done. Okay. So this is something I want you to do it yourself. So you create a variable and assign it the integer value of 30, then have the code display the type of variable used. Create a variable and assign it the float value of 9.87, then have the code display the type of variable used. Create another variable and assign it a Boolean value. So when you print the variable, you get a value of true returned. And I want you to also create three variables, all strings, and concatenate them together. And modify question 4 with comment at the top. Then create a variable, assign it the integer value of 30, then have the code display the type of variable used. So when you do it yourself, this is how you should go about it. Then these are the answers. So when you finish, just check. Create a variable and assign it a float value of 9.87. So you created a variable, you've assigned, and you want to display. Good. So these are the answers. So just try and solve it yourself when you go through and see how it all pans out. Okay. Then you modify question 4, you would comment at the top. Yeah, that's it. So well done for staying through for our second lesson, and see you in the third lesson. And I believe this has been impactful and it has clarified or demystified some of your misunderstanding when it comes to data types. Do not forget to subscribe. Thank you.